To programming, in function programming, we also need to handle the scope of the variable, which define that the syntactic structures that a variable would make sense. Okay, for example, over here, that this variable x, it only makes sense within the scope of the first lambda abstractions, and this another variable x, it only makes sense within this in the so-called scope of the second lambda abstractions, and they actually mean two different variables. Okay, how do we differentiate them in terms of reduction rule? Okay, in order to do that, we have to make sure that we only apply the substitutions to the right variable, okay, or the variable that are in scope. So to define it formally, we have to introduce a meta function called free variable, okay, short form as fv. Okay, if you apply fv to a lambda term, that will give you back a set of free variable, or you can think about this free variable is the unbound variable, or is somehow defined in the outer scope, which is not mentioned in the current lambda term. Okay. For example, if you apply the free variable to the x, we give you back a singleton set x. If you apply free variable to a lambda abstractions, and we first have to compute the free variable of the function body e, and then we're going to remove the variable x, because x, it was introduced in this lambda abstraction, so is x in the context of here is no longer free because it's already been defined or introduced as part of the lambda abstractions. And when we apply the free variable to a function application, that where E1 applies to E2, and we simply compute the free variables in E1 and E2 and perform a set union of the two. Okay, for instance, if we compute the free variable of this lambda term, okay, because we see that this is one lambda abstractions, okay, and we first need to compute the free variable of its body, which is this part, okay, and then when it's done, we need to subtract away the formal argument x. So if we work out the detail and we look at this, the free variable of this is basically a free variable of a function applications. Then we compute the free variable of the first term. This is my E1, and the free variable of my E2. Okay, so this one is simple. We get a singleton set containing x, and we union with the free variable of the second part, which is this one. So if you work out the detail, and then this one will give you back, wow, it's a function, it's a lambda abstractions. I have to compute the free variable of this body, and then subtract away the formal argument z. Okay, so in turn, eventually this will give us a y, okay, and z union with z, okay, and then subtract away the z, we get back y and z, subtract z, so this will get back y, and then x union with y, you get back x and y, and subtract x, we get back y. So the free variable for this entire term is y. Form beta reduction is called capturing the free variable. So this can be detected by computing the free variables from the terms. For example, consider this lambda term or lambda program is on the top level is a function application where we apply these lambda abstractions to another term, which is a function application. So note that if you work out the math following the previous slides, the free variable of this entire lambda program is y and w. Okay, so let's say we try to naively run this program using beta reduction rule. So by looking at this, first we're going to take the formal argument of this lambda abstractions, we put it here and construct a substitution by replacing x with the actual argument, which is y applied to w, and we're going to apply this substitution to the body of this lambda abstractions, which is another function that takes y, that expect a y and return x applied to y. Okay, notice that if we apply substitution naively, okay, we simply, if we just replace x, this x, by the y and w, we get back another lambda term that expect y and return y applied to w, then apply to y. But the issue here is that we are accidentally putting the free variable y, which coming out from the outer scope, into the inner scope. Now suddenly this y in red, highlighted in red, is being put in the scope where y was introduced by the blue lambda abstractions, and which is wrong. This would create an unexpected outcome of the program evaluation.